In JavaScript, some things aren't just syntax. They're basically superpowers. And today, we're going to dive into one of the most fundamental of them all, the callback function. It's the secret to how JavaScript handles our complex, interactive world, and we're about to see exactly how it pulls it all off.
So let's just start with a puzzle. We all know JavaScript is single-threaded, right? It can only do one thing at a time. Its call stack is like a to-do list where you can only focus on the very top item. So how in the world does it handle a 5-second timer or just wait for you to click a button without freezing the entire browser? The short answer? Callbacks. But the real magic is how JavaScript uses them to work with the browser. To really get that magic, we first have to get our heads around one core principle of the language. It's this idea that in JavaScript, functions aren't just these rigid blocks of code. They're way more flexible than that. And that brings us to this key term, first-class citizens. And really, all this fancy term means is that you can treat a function just like you treat a number or a string. You can stick it in a variable, you can return it from another function, and, this is the most important part for us today, you can pass a function into another function as an argument. This one rule, it's the foundation for literally everything else we're going to talk about.
So let's look at how this actually works. It's super simple. You've got function y, you pass it into function x. The moment you do that, y becomes what we call a callback. You're basically handing over the reins, telling function x, hey, you are now in charge of running y whenever you decide the time is right. Okay, so with that in our back pocket, let's look at the classic example that makes this all click, the timeout function. This is where we get to see callbacks solving that first puzzle of how to wait without blocking everything up. Imagine that single JavaScript thread is like a single railway track. Every task is a train that has to go down that one track, one after the other. Now, if one of those trains just stops and decides to wait for 5 seconds, it should cause a massive pileup, right? It should grind everything to a screeching halt. But it doesn't. So what's really going on? Well, when your code hits setTimeout, JavaScript doesn't just sit there and pause. Instead, it takes that callback function you gave it, and it hands it off to the web browser's own set of tools, along with the timer. It's basically saying, hey browser, you hang on to this for me and start a 5,000 millisecond timer, would ya? And this right here, this is the crucial part. JavaScript does not wait, not for a second. It moves right on to the next line of code and just keeps on chugging along until its to-do list is completely empty. It's like the perfect delegator. It gives the waiting task to someone else so it can get back to its own work. Meanwhile, in the background, the browser's timer is just ticking away. 4 seconds, 5 seconds, and time's up. Okay, this is the magic moment. Once that browser timer finishes, it waits for JavaScript's main to-do list, the call stack, to be totally empty. And then the browser takes that callback function it was holding onto and pushes it right onto the stack to be run. And that is asynchronicity in action, handling these long-running tasks without ever blocking the main thread. Now, this whole powerful idea isn't just for timers. Oh no, it is the engine that powers pretty much the entire interactive web, from the moment you click a like button to when you submit a form. Yep, every single time you use something like add event listener, you're using a callback. You're telling JavaScript, hey, keep an eye on this button, and when and only when someone clicks it, please run this function for me. And the flow? It's exactly the same as setTimeout. First, you attach the listener, you give it your callback, then the program just keeps on its merry way. It doesn't wait for you to click. But the moment you do click, bam, the browser places that callback function onto the call stack to be run, and your action gets triggered. All right, now this is where things get really, really cool. What happens when we mix callbacks with another huge JavaScript concept called closures? Well, we basically give our callbacks a memory. So let's think about a classic coding challenge. You need to make a button that counts how many times it's been clicked. Simple enough, but here's the catch. You are not allowed to use a global variable to store the count because, that's just messy and asks for trouble. So how would you do it? Well, the answer is closures. Think of it like this. When a function is born inside another function, it gets a little backpack. And in that backpack, it keeps all the variables from the place it was born. It remembers them, even long after that place is long gone. So the solution is just beautiful. We set up an outer function that declares a count variable. Then inside that function, we create our event listener callback. Because that callback was born in that environment, it forms a closure. It gets that little backpack with the count variable in it. So now,
Every single time you click the button, the callback can reach into its own private backpack, find count, and update it. The state is perfectly preserved between clicks, totally safe from the outside world.
But you know what they say, with great power comes great responsibility. This combination of event listeners and closures is incredibly useful, but it has a hidden cost that every single professional developer needs to understand, and that's memory. Just take a look at this. Having a few event listeners on a page, no big deal. But what happens when you start scaling up, attaching hundreds, maybe thousands of them, for example, on a long list of items? Well, you can see the memory usage starts to creep up. A lot.
So here's the bottom line, something you really need to remember. Event listeners are heavy. They cost memory. And now we need to know why.
And it all comes back to closures, doesn't it? Because that callback might need the variables from its backpack at any moment. The JavaScript engine can't just throw them away. It has to keep that entire environment in memory, which prevents it from being cleaned up or garbage collected. Now multiply that by 1,000 listeners, and you can see how your page starts to feel sluggish. And this brings us to probably the single most important best practice here. If you attach an event listener, you have a responsibility to remove it when it's not needed anymore. When a component disappears or an element gets deleted, clean up those listeners. That's what lets the browser finally free up all that memory. So yeah, callbacks are a superpower. They let this single-threaded language, JavaScript, manage an incredibly complex asynchronous world. But as we've seen, that power, especially when you mix in closures, comes with a hidden cost. So the real question for you as a developer isn't just if you're using this superpower, it's are you using it responsibly? Are you remembering to clean up after them?